Today on Real Chemistry, we're going to be talking about solution stoichiometry. What's that? Well, stoichiometry, remember, is just thinking about chemical recipes, that is, chemical reactions. And we can think about how much product we can get out by thinking about how much reactants we put in. To review stoichiometry, I recommend you watch my video, Introduction to Stoichiometry, before continuing. So now basically we're taking this idea of stoichiometry, that is how much of a chemical reactant we put in and how much of a product we get out, and we're combining it with another concept we've learned, molarity. So if you're not familiar with molarity, I recommend you also watch that video before continuing. So here what we're going to do is we're going to think about adding solutions together and thinking about how much of a reactant or product we're adding in terms of the volume of a solution and its concentration. So let me give you an example of a question we might ask. You might want to know if I'm reacting hydrochloric acid with sodium hydroxide, and that gives me water and sodium chloride, how much water would result if I put in 1 liter of 3 molar HCl with excess sodium hydroxide? So here what we're thinking about is running this chemical reaction with a solution of hydrochloric acid. And we want to calculate how much water results when we run that reaction. Let me show you a game plan for how we're going to go through these types of problems. So this chart tells us about how to do stoichiometry problems. In fact, I recommend you go ahead and just pause the video and copy this chart down now. It's going to be helpful for you in the rest of the video, and it's going to be helpful for you whenever you do a stoichiometry problem. And what we can do is we can start on any one of these squares, and we can go to any one of the other squares using the conversion factors that are listed in the yellow. So in this case, we want to know how many grams of water result from a 1 liter solution of 3 molar HCl. So here, eventually we want to get to mass of products, which is over here in the green. So we want to get down to here, and we're starting with a volume of a reactant, a volume of HCl. So we start here, and we want to eventually get down over there to that mass. How are we going to do that? Well, we're going to go from volume of our reactants to the moles of our reactants using molarity. So we're going to go from here to here using this guy, molarity. And once we have moles, we know we can just go ahead and use our chemical recipe. Remember, our chemical reactions are always written in terms of moles. And that means we can't just think about the ratio of volume that goes in and out. We have to actually think about the ratio of moles. So that's why we go to moles first. Now, once we have moles of the reactant, moles of HCl in this case, we can go to how much product we're going to form using the chemical recipe. Now, the last step is we're going to go from the number of moles of product we have to the mass of product using molar mass, just as you'd expect. So again, this is a lot to learn at once if you're not already pretty familiar with molarity and stoichiometry. So check those videos out if you feel a little confused. All right, so let's actually go ahead and do this. We're going to go from volume to moles of reactant, from moles of reactant to moles of product, and then from moles of product to the mass of product, in this case, the mass of water. Now, how is it that we use molarity to go between volume and moles? Well, recall that our molarity equation is just molarity is equal to moles over liters. And what that tells me is if I rearrange that equation to liters times molarity, then that's actually equal to moles. And so what I'm going to do then is I'm going to plug in the volume of my solution, 1 liter, and the molarity of my solution, 3 molar. And that's going to give me out how many moles of HCl I have. So 1 liter times 3 molar HCl gives me 3 moles of HCl. Now that I have moles, this is basically a normal stoichiometry problem. So if you're familiar with molarity and you're familiar with stoichiometry, combining these two isn't so hard. But the trick is to be pretty familiar with both. All right, now that we have moles of HCl, we're just going to use our chemical recipe up here to go between the moles of HCl and the moles of water we're going to get. And this reaction just tells me that if I put in 1 mole of HCl, I get out 1 mole of water. So if I put in 3 moles of HCl, I'm going to get out 3 moles of water. And the way we can do that with a conversion factor is we just start off with 3 moles HCl. And then we're going to cancel out the HCl. And we're going to get water. So we want to get rid of HCl and we want to get water. And then we fill it in with the numbers, and there's a 1 in front of both of those. Even though it's not listed, it's just implied. So there's a 1-to-1 ratio in this case. And that, we'll notice, cancels out my HCl, and right now leaves me with water and moles. And so from there, if I want to go from moles of water to grams of water, that's where I'm going to use the molar mass. And the molar mass of water, which is used pretty often, is 18.02 grams. So 18.02 grams, and we want to cancel out moles, so we put 1 mole on the bottom. And we notice now we get rid of our moles, and we're left with just grams and water. And if we plug that into our calculator, to 1 sig fig, we'll get 50 grams. So that's the answer to our question. We've put in 1 liter of 3 molar HCl into excess sodium hydroxide. And we wanted to know how much water we could form. It turns out we can form 50 grams of water. So we're just thinking about chemical recipes, but we're doing it in terms of stoichiometry. Let's take a look at one more problem. So here we have the reaction of lead nitrate reacting with potassium iodide and going to lead iodide and potassium nitrate. And the question asks, what volume of 0.2 molar potassium iodide is required to form 12 grams of potassium nitrate? So notice that here we're given information about the product, 12 grams of potassium nitrate, that's this guy. So we're given information about the product, and we want to go back to the volume of potassium iodide we must have added. So this is a common type of stoichiometry problem where instead of going from the reactants to the products, we're given how much comes out and we have to back calculate. So how are we going to do this? Well, let's go back to that flow chart we have, and it's going to help us think through this process. So in this case, what we're starting out with is we're starting out with the mass of our product. So we're starting out over here. This is where we start out initially. And what we're going to do is we're going to go from the mass of our product to the moles of our product using molar mass. And then we're going to go from the moles of our product to the moles of our reactant using our chemical recipe. And then finally, from the moles of our reactant to the volume of our reactant. That's where we want to be, because it asks what volume of 2 molar or 0.2 molar potassium iodide we need. So those are the steps we're going to follow. And if you can write out this flow chart, you can map out what steps you need to do. So let's go ahead and give it a try. We start out with 12 grams of our potassium nitrate, and that's a product. So we're on the product side. And before we can use our chemical recipe, we need to go to moles. And if you look up the molar mass or calculate the molar mass of potassium nitrate, it's 101 grams per mole. And this time we're going to divide by grams because we want to get rid of it. And we'll have 1 mole up top. And when we do that, we're going to get to moles of KNO3. And if we want to go from moles of this guy, KNO3, to moles of this guy, potassium iodide, then we have to use our chemical recipe. We have to use those numbers there to help us figure out what ratio these things react in. So we want to get rid of KNO3. So I write KNO3 down here. And we want to get out potassium iodide. So we write Ki up here. And both of those, we'll notice, have a 2 in front of them in their recipe. So we're going to write a 2 over a 2. Now, we're going to go ahead and calculate what that gives us. That's going to give us moles now of potassium iodide because our grams cancel out and our KNO3 cancels out. And when we do that, we get 0.12 moles of KNO3. Or I'm sorry, of Ki. So that's just a normal stoichiometry so far. And all we're going to do at the end is we're going to add a step where we once again use our molarity equation down here. And this equation tells us that molarity is equal to moles over liters. So if we rearrange that equation to solve for what the question is asking for, which is our volume, then what we'll actually get is volume, or our liters, is equal to our moles over our molarity. And so if we take our moles, 0.12, and we divide it by our molarity, 0.2, we'll get out that we need 0.59 liters of our potassium iodide. And so that's the answer to our question. What we've done in this problem is we've taken a product. We've formed 12 grams of potassium nitrate. And we've back calculated what volume of a solution of potassium iodide we needed. So this is just another wrinkle in the stoichiometry problems. All we're doing is combining what we know about concentration with what we know about stoichiometry. So if you're still not sure about what to do here, I recommend you go back, watch the stoichiometry videos and the molarity videos, and then come back and give this one another try. If you still have questions, please ask them below. Also subscribe to my channel to get updates about future chemistry videos.